This is Narayana. Uh, Today topic in last class we discussed with CAN protocol like what is the host, what is the controller, what is the transmitter, and why used 120 ohm resistors in both sides in CAN protocol. So we will discuss in last video, but today topic is the CAN voltage levels. What is the CAN voltage levels? What is the dominant? What is the recessive bit? And uh, how the differential voltage calculations we will discuss with today, and what is the serial communication, what is the parallel communication, how it works in CAN protocol. So we will discuss with this. So more in first of all, what how many types of CANs, or what is the identifiers, how many identifiers, what is the standard CAN, what is the extended CAN. Okay, I will discuss. Okay, a part A, CAN is a two parts, which is CAN 2 0.A or 0A, and CAN 2 0.B is the two types of CAN CAN protocols as there. So the specifics of the 11-bit identifier of a CAN, which has 11 bits. Okay, it will transmit a 11-bit identifier. So one is that is nothing but a classical or standard CAN. Or part B is specifications of 29-bit identifier of a CAN, which is nothing but a standard CAN. So we will discuss with what is the standard CAN, what is the configuration of standard CAN, and how it works, how the bit transmission will happen. We will discuss in next video. First, today we will discuss with voltages. What is the CAN voltage levels? So in this CAN voltage levels, the low voltage of a CAN is 0 volts, and the high voltage of a CAN is 5 volts. So in this 0 volts and 5 volts, when we give the signal, if some if you send the signal will be a wave, right? So some of the signals will be waves. How it means, see, this is the signal. I think you was I'm sending this signal. Okay, so this is the high voltage level, and this is the low voltage level. So same way, this is the 0 volts is a low voltage level of a CAN, and 5 volts is a high voltage of the CAN. So here, to calculation of these voltages, we comes a picture which is dominant bit or recessive bit. So here the dominant bit is 0 and recessive bit is 1. So how can you calculate the CAN voltage levels? Means, see here. See, this is the graphical representation I am giving you. So this is CAN graphical representation I am drawing here. See once. So we will give here 1, 2, 3, 4, right? This is a 0. Okay. Next, this is the 1.5. You can take it as 1.5. This is 1.5. This is 2.5. Take as a 2 and 2.5. See, and it will take as a 3. Okay. Next 3.5. We can take here another one, 3.5. See, I take as a 3.5. So here we can calculate the voltage. So 0 to, so it is a dominant voltage starting with 0 to and 3.5. It will in between 0 to 3.5, it is a dominant voltage. Is how it calculate dominant voltage is, so calculation of dominant voltage is the 1.5 to 1.5. See here, 1.5 to 3.5, right? So how to calculate the differential voltage means, the differential voltage is nothing but the high voltage minus low voltage. So the dominant voltage will be calculated from 1.5 to 3.5, right? So highest voltage is 3.5 here. So I take it as 3.5 minus 1.5. What is the differential voltage is? It's a 2 voltage. So 2 volts is a dominant voltage here. So next, coming the recessive means recessive mode. So the dominant highest priority, which is voltage, and recessive is a differential voltage of recessive means the differential voltage of recessive bit is 2.5 to 2.5. So this is the recessive voltage. So we can calculate 2.5 minus 2.5, we will get the 0 volts of the differential voltage. So it is in a recessive bit. So when we get the 0 voltage, it is in a recessive bit is nothing but 1. So when we get the two differential voltage or some differential voltage, you can get that voltage is nothing but a dominant. So what is the dominant bit means here? 0. Dominant bit is 0. So see here, I'm giving the one example. So 8, okay, I'm giving the 8 as a input, okay, and 10 as a another input. See which one it goes first into the CANBus. How can you say that these? But your computer knows only the binary language, right? So computer knows binary language, which is zeros and ones. So it will converting. So how it converts? So binary value 1 2 4 8. This is the binary code which we are using. So I am giving the input as 8. See, I taking here 1 as a, see, this is the 1. So 8. Remaining will be 0. Remaining all zeros. So in 10. So 8 plus 2, 10. So remaining is zeros. So this is the binary conversion. So after this binary conversion, how it will transmit? So for example, I am giving the 8. So 8 and 10 at a time. So I'm passing the two signals at a time from the CANBus. How it calculate and how it gives the, how which one is going to the first, so into the bus. So it will takes 0 first bit, and it first bit also 1. So the both are same. So the can will goes to second bit. So it will goes second bit. This is a 0. So this is a dominant bit, right? So every dominant, when we get the dominant bit or 0, when we get 0 in first, which message get 0 first, so that message will goes to CANVAS, right? So here also a 0. So I'm sending two at a time. So this is two also zeros, right? So these two also equal. So it will consider another bit. So it is a 0 and this is the 1. So who gives the priority first? Who gave 0 first? After the bit. So it is a 0. This is the 1. So it is a dominant bit. So it will goes first to the bus. 8 will goes CAN bus first. After that the 10 will goes to the bus. So this is the example how it will goes into the CAN bus. How it will travel from the bus one message to another message. So it will transmitting the data from one ECU to another ECU. So here, what is the serial communication? How the CAN is in a serial communications, right? So it will supports the most MSB bit, means most significant bit will transmit first. So here the dominant bit is goes to first. So coming to serial communication, right? The CAN is in a serial communication. How it transmit from one after one. So what is serial communication? It is the way transmitting the data in a line, one data after another data. See, it will transmit bit by bit. So it will transmit one bit. See, this is my data. So I am transmitting 4 bits, right? So it will transmitting data. So it will transmit one after one. See, first 0 will transmit, after that it will transmit 1. See, it transmit 1, after that it will transmit another 1. So this is the another one. So after that it will transmit 0. So this is the serial communication. So it will transmit one bit after one bit. So see here, 0, see 0, it will transmit 0. So 1 after 1, next one, next one. So this type of scenario, when the order of the data bit is important, it dedicates how the transmission is organized when it is received. So it will receive the bit by bit. There is no errors from the bit. So another data will stop there, or another message will stop when the first taking message is completed. After the completion of first message, then only the receiver will take the second message from the sender. So there is no mismatches with the two messages. So it views as a reliable data transmission method, because a data bit is also a send. If the previous data bit has already has been received, so it will check which bit will getting, or previous one, or new one it will getting. So it will takes, each and every message contains a id. So every message will get ids. So it will divides the messages will receiver. However, we have to use the signal connections to transmit the data. So it will based upon the signals, or connect communication oriented. So it ignores each and every message, because if the receiver, each receiver dedicates to process or ignore each message, hence the message oriented communication. So when we get the communication in the message oriented, then only it will receive. After that, if you send in a signal form, or if you can send digital format, it will not receive, because your sender will be sending the message format, your receiver also sending, taking from the message oriented only. So has a reliable and robust will prevent the technologies, like low, so local supported error dedications to transmission and for the conflict uh, topologies, or inexpensive like bus standard levels. So which we can demand the standard levels of the can. So it will transmit the data from one after another one. So in the serial communication, what I have to tell you, the bit transmission is conducting from one bit after another bit. So the can will prevents that it will transmit a bunch of messages at a time, and it will transmit, it will take the data from one bit after one. So this is the serial communication. Here we have to use the signal connections to transmit the data. So in this serial communication we are using the signals. So when we giving the signals, if the signal is low, sometimes the message receiver time is also more. So some misconnections will happen. So in this serial communication, so the it will transmit the 8 bits of data. So when we transmit the 8 bits of data, it will take 8 seconds. For example, you take 8 bits will take 8 seconds. So what happened in this 8 seconds, the message will, receiver will read the message, which one is the error bit, or which is the dominant bit. So it will take a bit oriented. So in this data bit is also a send if the previous data bit has been received or not. For example, if you send a data, if the data is received or not, it will gives the acknowledgement to the ECU. It will send again acknowledgement if the data is received. Your sending data will be received from the receiver, so it will send the acknowledgement. So in this serial communication, so coming to the parallel communication, what happen in parallel communication? When the data is sending, when the data is sent using a parallel data transmission, the multiple data bits are transmitted over multiple channels at the same time. So it will takes the multiple channels, or see, your can have a multiple ECUs, right? So it will gives the information with multiple ECUs. So at a time, and it will takes the messages from multiple ECUs at a time. So this means the data can be sent much faster than using the serial transmission method. So when we using the parallel communication, it will send the message to all the ECUs, and it will receive the message from all the ECUs at a time. So here the time is very faster to receiving, or action of the ECU will be more accurate, because that message is receiving, the ECU activate, and ECU will do the work. Whatever the work you assign to the ECU, it will do. So here the work or time is more effective in this parallel communication. When is parallel transmission used to send the data? The parallel transmission is used when means a large amount of data is being sent. So when we are sending the large amount of data at a time, so it will useful to send by using the parallel communication. The data next one, the data begins to send this time sensitivity. So it will send the time sensitivity. So it will reduce the time, and it is a very send quickly to needs the data, send quickly to receiver from the see. For example, you are traveling the car, your car will get an accident, your airbag is not open. So what is the use of airbag? There is no, your airbag is not open, your head will hit the steering, uh, the person will injured. So there is no use, right? So when the ECU will quickly reacted, it will use the instruction to airbag to, when the crush happens in seconds, then airbag has to open. So this, when the airbag is open, your head is hidden to the airbag, so you didn't injure. So this is the useful, right? So same way, when we give the instructions or large amount of data or number of messages we have, so we have to use the parallel communication to communicate with all the ECUs. So we will get the instruction is very quickly, it will saves the time, and it will reduce the time usage, and it manage the time management also, power consumption also. So quick reactions of the ECU will conducted by the parallel communication by using of serial communication methodology. So this is the parallel communication. So the bus architectures wide and can logic. So here I what are the logic? The can, which logic will follows? It will follows a and logic. So and gate logic. So note that inserts the input low producer output high. So input will be low, the output will be high, and vice versa also known as a inverters. So when we use the inverters, so inverters will, the input will low produces, output is high, and vice versa. Sometimes the input is high and output is also low, sometimes it happen. So in AND gate output is high only, if all the inputs are high. So for example, in AND gate will follows when the output is high, then the input is also high and the output is also high. So output is high in AND gate only if all the inputs are high. When the input is high, then only the output is also high. So but in OR gate is high, output is high if the input is high. So these two gates are vice versa, right? So why AND gate is CAN means the reason is very every CAN transceiver is a high internal transmitter, transistor, emitter, base and collector. So these transmitters are different allows to voltages or power transmissions when it is an a recessive one. If it also only when the dominant zero. So, for example, if you can see here, what an AND gate, the output C is a two input AND gate. So, see, this is the 0, this is the 0. So, what is this is the two dominants, the output is dominant. So, see here, one is dominant and one is a recessive. The output is also dominant. So for example, this is a recessive, this is a dominant. So output is dominant. If the both are the both are recessive, then only it will recessive. So you see here, this is dominant, this is dominant, this is the dominant. If OR gate, so here in AND gate, every bit in message, see here A and B and AB. See here, every dominant or if any one bit is dominant, then it will dominate. So it is a high voltage. So it will gives the high input and high output. Here see, any one of the bit is recessive, the total bit is recessive. See here, see 0 is a dominant, you can think 1 is a recessive and the output will be recessive. So if one bit is recessive, then the total output is also a recessive. So this way we are using the AND gate in a CAN protocol because the CAN will gives the high output. So only if all the inputs are high. See here, for example, this is the low. So these two are the recessive bits, then only it will gives the recessive. So if any one of the recessive bit here, so this is not bothered about it. It will gives the high voltage. So that's why we are using AND gate here. So this is about today's section. So please like, share and subscribe my channel and we are getting near to 100 subscribers. So please like, share and subscribe my channel for more videos. Thank you for watching.